Janitor here, and this is your lesson of the week, encoding for upload. The bottom line is that if you're encoding your MES files at 30 megabits per second or above to upload to a UGC or online video platform site, you're wasting upload time with minimal impact on video quality. This lesson is included in Streaming Media 101, which is used by companies like Dolby and Bitmovin and many others to onboard new streaming media professionals. So here's our agenda. We'll look at the fundamental trade-off involved in encoding for uploading. We'll look at how much data rate is enough, and then we'll look at some common specs from different services. So here's the trade-off, and you probably know this well. When you're uploading to a UGC service or an online video platform, they transcode your file for distribution. So you upload one file, say an MP4 file, and then it's transcoded into different rungs of an encoding ladder for distribution to different platforms. Now, we all know that video is a garbage in, garbage out medium, so you want to upload a very high quality file. But higher data rates or editing formats like ProRes dramatically increase upload time, which can cause errors. So I used two test files in this analysis, and the first was Sintel. I grabbed the trailer for Sintel, which is in PNG format, so a very high quality format, and then using FFmpeg, you'll see the commands in a moment, I output ProRes files and then MP4 files at these data rates. And then I computed VMAF with the Moscow State University Video Quality Measurement Tool and compared the output files to the PNG input. And here's how I created the ProRes files. Here's how I created the MP4 files, the mezzanine files. It was 2-pass constrained VBR encoding. And here's how I created a full encoding ladder. So we had one pass up here, and then we used that one pass for all of these outputs. And then here are the results. And I looked at a complete encoding ladder from 1080p 2500, and I used 2500 here because I wanted to achieve a VMAF score of around 93 to 95 for the top rung of the encoding ladder. I could have encoded at 6 megabits per second, and then this would have been 99, which is higher than anybody needs to distribute, and we would have seen very little difference in the encoding quality because the data rates were so high. So this is a pretty realistic encoding ladder for animation. It's a little bit different for the next clip that we used. And complete encoding ladder, this is average VMAF quality, and this is low frame quality. And these are the rungs in the encoding ladder here. And these are the VMAF scores with ProRes input, 100 megabits per second, 50, 40, all the way down to 10. And here's the maximum delta. So the biggest difference in absolute VMAF points between the lowest quality, which is always in orange, and the highest quality, which is in green. So what we see here is that ProRes was always the lowest quality, and the highest quality was spread between 100 megabits per second for this particular rung, around to the other encoding bit rates here. But again, the max delta for the top 3 bit rates are insignificant. So whether you're doing it in ProRes or 10 megabits per second, no viewer would notice the difference here. I also looked at low frame score, which is a predictor of transient quality problems. And what we see here is that we see very low scores here that are 11 points and 19 points different than the high scores here. So we're going to look at these frames and make sure that there were actual differences there. So, if you look at this chart, you basically see, I'm really not sure I want to mess with ProRes because here it gives me the worst average quality, and here it gives me the significantly lower quality in these lower rungs here. And this is what it looks like graph-wise. So this is mean VMAF. And again, there's very little difference in quality between ProRes down here and 10 megabits per second down here on any of the encoding rungs. We see that ProRes is a little bit lower here and here. This is mean VMAF average score. This is low frame VMAF. And then here we see again the significant drops in quality relating to ProRes in the lower rungs here. So whenever you see a score like that, you want to look at the actual frames to make sure that the scores are representative of actual quality. So what I did was I analyzed the files in the Moscow State University tool. These are the 360p files at 400. The ProRes files in red, and this are all the frames. This is the VMAF score across all those frames. And we see 3 areas where there's significant diversions. Here we see ProRes dropping significantly. Here we see it dropping again. And here's where we see 2 drops where the 10 megabit per second file is also pretty low quality here. So we're going to look at all these frames. And here's the source for the first comparison. Here's ProRes, and we see significant difference in the text there. And then here's the 10 megabit per second file. And if we toggle back between ProRes and 10 megabits per second, ProRes is obviously more impaired than 10 megabits per second. So all of these lines are impaired with ProRes. This line is readable with 10 megabits per second. So this is the second comparison point. This is the source file, ProRes again, 10 megabits per second again. So we see that the actual low scores that were shown in the second table, the low frame score, are justified by the difference in video quality. Again, this is ProRes, 10 megabits per second is clearer. And then here's some actual video. This is source, this is ProRes, this is 10 megabits per second. And these are 360p files, which is why they look a little bit blurry, but still not terrible. This is the source, this is ProRes, this is 10 megabits per second. I would say it's a little bit clearer around the eyes, but the overall quality is about the same. So that's our first test file, that's Sintel. Now let's look at the second test, which involved the Tears of Steel video, specifically the last 4.5 minutes, which is pretty active scenes, both computer generation and live human action. What I did here is I took the Y4M input, and then I output ProRes, and then MP4 files in these bit rates, and then I compared the files I encoded from these mezzanine files to the original Y4M input here. And here are the FFmpeg command strings that I used to produce the ProRes file, the MP4 files, and the encoding ladder, which has 6 rungs instead of 5. And here are the results. These are the mean scores, and these are the low frame scores. And what we see is that 100 megabits per second delivers the best quality in all cases in terms of mean, but the delta is pretty small, and most of that delta is between ProRes and the 100 megabyte file, not these, except in the top rung ladder case. Here we see an improvement of around 0.96 VMAF between ProRes and 100 megabits per second, and then it goes down very slightly through here where you're starting to see, I mean, I wouldn't call 0.52 significant, but it is much higher than the differences that we see here. And in terms of low frame score, we're still seeing pretty modest differences between the highs and the lows in the 1.8, 1.73, and this is the file that we'll look at in a moment to see if the difference between the 10 megabit per second file and the 20 megabit per second file will be perceptible by viewers. Here's the chart for mean VMAF. Again, we see an uptick in quality from ProRes to 100 megabits per second, and then a very gradual decline, pretty much irrelevant, between 100 and 30, and the biggest decline, as we saw in the table, was between here and here. And that's pretty consistent through all these encoding rungs. In terms of low frame score, not a lot of difference here. Again, the file that we saw the most difference was in the 720p at 1.8 megabit per second file. And we see a slight degradation in all these cases, but nothing that you would expect to be visible. So here we're comparing the 20 megabit per second file, which was the highest low frame quality in the 720p at 1.8 megabit per second file, against the 10 megabit per second file, which was the lowest. And I believe the delta was around 4. And the region where the difference was most was here. And I zoomed in here to produce this view here. And this is the frame that we're looking at. So the red value is around 2 or 3 points higher than the green value. And again, the green is the 10, the red is the 20. And this is the source, and this is a 1080p. This is 20 megabits per second at 720p, so it's a little bit less clear, and this is 10 megabits per second. So because of the nature of this shot, this is when the robot is changing a lot. Few viewers would notice the difference. It's a very short drop in quality, and because there's so much motion, it would be hard for most viewers to see. Long story short, even in this particular analysis, there's not much reason to be at 100 megabits per second as compared to 20 or even 10. Now, before you produce any files, you should check with your UGC site or online video platform site to look at their recommendations. And if we look at YouTube, they want the H.264 codec using the high profile, which is what we did, AAC audio, which was what we did, MP4 containers, what we did, and then the data rate they're recommending for 1080p is 8 megabits per second. So they're way low in terms of even the files that we compared. And if you're going to do 48, 50, or 60 frames per second, they recommend going to 12. And you can find the specs there. This is Brightcove, a very popular online video platform. They recommend the same in terms of codec and profile. And the data rate they're saying is for 1080p around 8 megabits per second, but if it's a talking head, you can go as low as 6 megabits per second. And you can check out their file specs there. Vimeo, another popular site, they're saying 10 to 20 megabits per second for 1080p, right along with our recommendations, or you can use CRF 18 or lower, which they talk about down here. And those are the audio specs. And as a reality check, these recommendations are just that, they're recommendations, and your video probably won't get rejected if they're not 100% compliant. So if you do encode at 50 megabits per second, Vimeo or YouTube or Brightcove isn't going to reject the video. Just make sure you get the codec right, and 10 megabits per second or a little bit higher should be sufficient. Get the frames per second. That should be the source. Resolution should be source, and audio. I would always use the source audio with the file unless it's something crazy like more than 320 kilobits per second. Now, what about ProRes? We saw in all of our analyses that ProRes quality, both overall and in some cases low frame, was lower than 100 megabits per second. So the question is, does transcoding ProRes to H.264 improve quality? So here what we did was we encoded the ProRes files to 1080p 4.5 megabits per second, just as it did before, and then we produced an intermediate mezzanine file from the ProRes input, which is this here, and then we compared both encoded files to the ProRes source. Here's the graph inside of the video quality measurement tool from Moscow State University. Red is the ProRes transcoded to H.264 and then encoded. Green is the original ProRes encoded directly to the 4.5 megabit per second file. We don't see a lot of difference here. And in terms of VMAF score, here's the H.264 mez, here's the ProRes mez. The difference in VMAF quality is 95.20 for the H.264 mez and 95.41 for the ProRes mez. So the ProRes mez is a little bit higher, which is what you'd expect. Same deal on the low frame score, but the difference is really, really insignificant. So obviously transcoding to H.264 won't improve quality, not a big surprise there, but transcoding won't meaningfully degrade quality either. So here in this experiment, we're going from 220 megabits per second to 50 megabits per second, and we saw just very, very little quality difference. Meanwhile, you're cutting your upload time by 80%. Conclusions. Regarding ProRes, if you store your mez files in ProRes, you won't improve quality by sending an H.264 encoded file. No surprise. So if you're currently sending ProRes, keep doing that. If you store your mezzanine files in another format, like JPEG 2000, I would encode to H.264 and upload at 20 to 40 megabits per second max, as opposed to ProRes. Don't rely on metrics without verification. Always look at the low frame scores and the frames associated with those scores, and always comply with the specs of your service.